Continuous probability distributions. So we just worked with the binomial and hypergeometric distributions. We also took a look at uniform distributions as well. And those ones deal with discrete data. So just to underline discrete data. So the values that we're working with were countable and discrete. Now, we will look at the normal distribution that considers continuous variables, okay, such as height, which has fraction and decimal values. Okay, first we're going to take a look at a couple distributions. So when we talk about positively skewed, what this means is that it occurs when the tail is pulled to the right. So this right here being the tail, and it's pulled to the right. Okay, if we take a look here, the mode is actually where the peak is, the median's to the right, and the average, so the mean, is very, very, very much to the right, where that tail really starts to sink down. So an example of this is the number of children families have in Canada is positively skewed because most people have 2 children, and the number of children increases. As the number of children increases, there are less and less families that maybe have those numbers of children. So number of children, maybe most people have 2 children, so that's a mode, and then maybe 3 children here, 4 children, and we don't really see a lot of people with 5 and 6 children, okay, and so on, so on. So that distribution is positively skewed, as well as income in a community ranges maybe between like $5,000 and $250,000, but most people fall somewhere between 50 and 75. So again, if we take a look at this and we erase that, let's go skinny, a little skinnier on the pen. Okay, so maybe like the majority, like the chunk of people, are going to be between $50,000 and $75,000 a year. And then as we get up there to like $250,000 income, not many people like see this area under the curve. That's what we're actually taking a look at. Not many people are going to be making $250,000. Okay, so now negatively skewed. This occurs when the tail is pulled left. So again, the tail being this part right here. An example of this is if a very easy test was given to the class, most children are going to do very well, right? So let's just say like a high score would be, let's say like 80 to 100 right here. And then because it's an easy test, maybe like this would be like 50%. So many of the students will score very high, making the test negatively skewed. Maybe the mode could be like a 90. So the most people in the class get a 90 on it. Okay, and another example of this is the age at which people retire. So we know retirement age in Canada is usually around 65 years old. So let's say 65. Okay, and not a lot of people will retire before that because the people that fall here, maybe let's say 55 years old and 45, they don't have enough money to retire. But some people still do retire, maybe because they stayed home with children or because they have enough money, maybe they won the lottery, okay, or they got injured. But most people are going to retire between maybe the ages of 60 and 70 years old. So the 2 distributions that we just took a look at are unimodal. And what this means that there's a single hump. So there's going to be 3 variations of this. There's going to be like the symmetric one, and we're going to get into that in this unit, which is the bell curve. And there's going to be positively and negatively skewed. So like this. But as you can see, there is one hump right here. This part right here for each of these. So now let's take a look at bimodal. What this means is like when we talk about modal, we mean mode. Okay, there are 2 humps in the distribution, so it may be like this and like this. So obviously 1, 2. There's going to be 2 modes in the distribution. So an example of this is when you're taking a look at different like adult shoe sizes. So I say adult because you want to take a look at individuals that are no longer growing, right? There may be one hump for men's sizes, which are probably going to be bigger, and one hump for women's sizes, which ones are like the most popular. So maybe women's would be a size 7 and men's would be like a size 11. Okay. And probability density, when calculating the area under the curve, and that's what we're going to focus on here is like the area under the curve. The area represents the probability, so the total probability. The curve itself represents the probability per unit of the continuous variable. Okay, and all that means there is like per unit. So like this is 1. So this is the probability of it being 1. And then let's go, this is 2. This is the probability right here that it's 2. Okay, and then this is 3. And the probability right here that it's 3, just for an example. Okay, so let's first take a look back at this uniform distribution. And this is the kind of distribution that we focused on in the first couple chapters when we were talking about like counting techniques with the permutations and combinations. A lot of these, like rolling a die, flipping a coin, okay, many of these are uniform distributions. So this is when this is a distribution where the probabilities are equal. Okay, so any event happening. So maybe like the probability of rolling a 1 is going to be equivalent to the probability of rolling a 2, is going to be equivalent to the probability of rolling a 3, and so on. So when we take a look at the actual distribution, so 1, 2, 3, 4, 5, 6, just as an example, it's going to be uniform. It's going to be the same height. It's going to be 1/6 for every single row. Okay, so the probability is just 1 over all of the outcomes for each of the outcomes.